Hey everyone, and welcome to this explainer on introducing the Web3 evolution, brought to you by the Foundry at Forge College. So if you joined us for our previous lesson, you know we spent a lot of time completely obsessing over APIs, web services, and all the security implications surrounding them. We talked about how APIs essentially act as the internet's ultimate gatekeepers. But today we are taking a massive leap forward. We're going to shift our mindset from those centralized bouncers to entirely decentralized networks. This is the absolute foundation of Web3. And honestly, it is going to completely rewire how you think about trust, access, and system architecture. Let's get into it.
Okay, here is our architectural blueprint for today. We'll cover the gatekeeper problem, Web3 principles, the cryptographic signature, content registries, a quick flow comparison, and finally, the new mindset.
All right, starting with Section 1, the gatekeeper problem and centralized trust models.
To really understand where we're going, we first need to understand the fundamental flaw of where we currently are. In a centralized API model, an API key or an OAuth token centralizes all of the trust into a single issuer. Think of it like a terrifyingly strict bouncer at an exclusive club, and this bouncer holds the absolute only copy of the guest list. If you want in, you have to prove to that specific bouncer that you have the right credentials. They are the ultimate, unquestionable authority.
But, that brings up a rather terrifying question for any systems engineer. What happens when the gatekeeper goes down? If that bouncer loses the guest list, takes a suspiciously long coffee break, or just decides they frankly don't like your face, the entire system stops working for you. Literally, you're locked out. It is a massive single point of failure and a huge concentration of risk.
Let's move on to Section 2, Web3 principles and our new architectural blueprint. To solve that concentration of risk we just talked about, we have to completely rethink our engineering blueprint from the ground up. Web3 essentially fires that centralized bouncer and replaces them with three core principles. First up, decentralization. Instead of a single operator deciding your fate, we use shared consensus across a whole network. Second, transparency. Instead of a private database hidden behind some corporate firewall, the state of the system is public. It's auditable by anyone. And third, composability. Because the rules are shared and open, different components can easily interoperate with each other. It's kind of like playing with open-source digital Lego bricks.
Section 3, the cryptographic signature. This is where we replace the API key.
So how do we actually replace the API key in practice? Well, we swap it out for a self-verifying, totally unforgeable digital ID badge. The protocol flow illustrates this beautifully. Step 1. The client hashes the message. This turns the exact data into a unique digital fingerprint to prevent anyone from tampering with your request. Step 2. The system uses cryptography to recover the signer's address right from the signature itself. And Step 3, it verifies that identity. Did you notice the missing step there? There is absolutely no password lookup in a central database. None. You prove who you are through pure, undeniable math.
Section 4, content registries, looking at Web3 in action.
Let's see this in action by imagining a decentralized content registry for digital artifacts. Think of it like a publishing platform. Notice how the creator signs their own metadata locally, right on their own device. That means authorship is proven entirely independently of any central account provider. You don't need a tech giant to say, yes, they wrote this. Your cryptographic key proves it for sure. And once it's broadcasted, that authoritative state lives on a transparent public ledger for the whole world to audit.
But, as any good engineer knows, there are literally no perfect solutions, only trade-offs. As you'll discover in other courses across the Forge College ecosystem, this transparency brings incredible benefits, like censorship resistance and non-repudiation, which is just a fancy way of saying no one can deny you published it. However, it definitely introduces new headaches. Having public data means privacy exposure. Plus, storing data on-chain is notoriously expensive and slow. This is exactly why developers often use hybrid models, keeping the lightweight cryptographic proof on-chain, but dumping the heavy, bulky data off-chain.
Okay, Section 5, flow comparison. Web2 APIs versus Web3 dApps. Let's put this into a side-by-side comparison for a standard write request. In a centralized API, Web2, your client authenticates and sends a post request straight to an operator's database. The operator validates it, writes it down, boom, done. But in a decentralized app, Web3, it's completely different. Your client constructs the payload, signs it locally, and broadcasts a cryptographically signed proof of your intent out to the entire network. And that network uses shared consensus to process your transaction. Comparing these features side by side really highlights the grand paradigm shift in pure engineering terms. Just look at authentication. We move from an operator handing you a credential to you generating your own cryptographic signatures. Authority completely shifts from a proprietary database you can't even see to a shared consensus that literally everyone agrees on. And transparency moves from opaque, closed-door server logs to public, mathematically verifiable ledgers. It is a fundamental rewiring of digital trust.
Finally, Section 6, the new mindset, exploring this paradigm shift. Because transitioning to Web3 isn't just about learning some new code syntax. It requires an entirely new way of thinking. Now, you don't have to forget your Web 2 skills. You absolutely still need to build great user experiences, but you do need to understand where the enforcement boundary moves. Take a second and consider this quote. Trust moves from gatekeeper statements to cryptographic evidence. We are no longer blindly trusting an operator's promise. We are trusting auditable, cold, hard math.
And because there's no central operator pulling the strings behind the curtain anymore, the client software takes on a whole lot more responsibility. The software running on the user's end is actively participating in proving intent. Your clients have to handle local signing securely. They have to manage nonces, which are basically numbers used once, to prevent someone from capturing your transaction and replaying it. And they have to actually query decentralized indexers just to read the current state of the network. It's a much more active, robust role for the client, for sure.
But this leaves us with a massive, highly provocative question. If there is literally no central operator, no CEO to call, and no customer service desk when things go horribly wrong, how do we actually resolve disputes? Who decides the edge cases, and how on earth is accountability enforced in a decentralized world? Well, that is exactly what we'll be tackling next as we move from mechanics into human coordination. Be sure to visit forge.college to continue learning, explore our other resources, and dive right into our next topic, trust and governance in Web3. Thanks for watching this explainer, and we will see you in the next one.